Hi, welcome to a new IGCSE video. In this video, we'll talk about 5 very basic concepts in mechanics, including speed, velocity, distance and displacement, and lastly, something called acceleration. Let's start with speed and velocity. I'm very sure that you have heard about speed somewhere in your life. For example, when we talk about the speed of a car on the highway, the speed of the car probably is 80 km per hour. And if you're talking about, say, a person that is running through a running track, say a 100 meter, if you look at the Olympic result, then probably you get a result of 9 point something or even faster. And let's just say it is 10 seconds, then by calculation, if you just simply divide it, then you can get it will be 10 meter per second. So that means that person can run for 10 meter in 1 second. So that is the idea of the speed. For velocity, also measure how fast the things moves. However, it also indicates one extra information, and that is direction. So that means where it goes. So for example, if a person also running at 10 meters per second, but when we try to describe its velocity, we may want to say, oh, this person is running at 10 meters per second to the right. Okay, so we have to indicate its direction. The reason why we need to indicate its direction, because later on when we calculate some other things, for example, for velocity, it will be useful for us to calculate its acceleration. And the direction will actually affect how we calculate acceleration. If this person is not moving to the right but moving to the left or going in other direction, that may affect the result or the measurement of the acceleration. More precisely, the way that I just now told you is not the best way of defining the speed and velocity. The best way of defining speed and velocity is through these two equations. Speed is actually defined as distance over time. More precisely, it should be the change of distance or distance that you moved over the change of time, so within a certain time. Velocity is similar. It will equal to, again, the change of displacement over the change of time. So when you try to find out the value of speed and velocity, you can use these two equations. So this picture already illustrates you the idea of distance and displacement. Let me explain. Imagine you start walking from here. So this is the starting point, and you walk along this green path all the way until the so-called ending point. All right, you just choose randomly within a time that you walk. So the path that you walk and the length itself is called the distance. Okay, so this may be, let's say, 200 meters. Okay, I just make it up. And within these 2 points, because you have a starting point and an ending point, then you must be able to draw a straight line, because for any 2 points you must be able to draw a straight line. So for this straight line with the direction also is called the displacement, right? So for its length it's called displacement. And this obviously must be shorter than distance, because you can never get this straight line to be longer than this path itself. And so let's say this may be just 50 meters. So your displacement will be 50 meters towards this direction. I don't know how you call it, but if you are given a direction, if this is north, then this may be something like south to east, whatever degree, right, that you are talking about. So this is the idea of displacement. So based on what I said, I would like you to take some time to put down the definition of these two. Do it now and pause the video.
A few moments later.
Okay, so here is how I will phrase it. For distance, it will simply be the length of the path that one moved. Okay, very simple. There's no direction involved, by the way. For displacement, that will be the length of the line that joined from the starting position to the ending position. So like what we said, starting and ending with the direction. All right, let's not forget this. We will need to indicate this direction. Here's an exercise for you to try based on what we learned about velocity, speed, distance, and displacement. I would like you to try it, so pause the video and try it first.
A few moments later.
Let me show you how I would do it. So first of all, I will always put down the general formula whenever I do a question in physics. So speed equals to distance over time. So this is definition. If you're a bit lazy, you can try to use a symbol. For distance it is d, for time is t, so you don't have to write such a long word. And so for distance, it's simply as all three parts of the length that add together. So 50 plus 212 plus 262 divided by the time. The time you can see from the question is saying 10 minutes. However, for the speed or velocity in physics that we calculate, we usually use a unit of meter per second. We don't use meter per minute. So here, other than dividing 10, you have to convert that into second as well. So how you can do it is by multiplying 60, because obviously 1 minute you have got 60 seconds. So you just have to press your calculator after this, and you will get something like 0.87 meter per second. So this is the speed that you get for Tom. For velocity, we should also put down the equation first. So that is the displacement over time. Again, you can use the symbol for displacement is actually s. So s over t. And the tricky thing is for displacement, as we said, it is the starting point and the ending point line that join together, and you need to find out the length of this. Alright, and this will take you a bit of geometry or trigonometry that you learn in mathematics. If you don't know this line is the displacement that we are referring to, I'll recommend you to pause the video now and try it by yourself first. If you did it already, let me show you how I would do it. So obviously this is more like a trapezoid, and you can actually see not really in good scale, I think. So but here this is 50 meter, right? This is kind of like right angle. So you can find the length of these by 262 minus 50, which is 212 also. So you have 212 on this side and 212 at the bottom, and for the question mark, which is the line that you are trying to find out, you can use Pythagoras theorem, right? And that will be 212 square plus 212 square and square root of it. So if you use your calculator, you can find that out, or I can actually write it here. And I mean, if you want really good presentation, then how I'll do is I'll do 262 minus 50 square plus 212 square. Okay, so the reason why I said this is a good presentation is because all this number is shown in the question, right, or in the diagram. 262 and 50 and also 212. Because if you somehow on the side you did some calculation, you can't expect the marker to know you did that, right? So for all the numbers that you show at the beginning of your question, it should be all from the question itself, or you can try to explain how you get that number. So yeah, that should be the one that you need. And again, you have to divide the time, which is 10 times 60 to obtain the second. So after calculating with your calculator, you should get something like 0.4996 something, and I will run it up to 0.50. Okay, and in the unit of meter per second. Alright, you may notice that strangely that the velocity somehow is much lower than the speed, but then this is very normal because, like I said, whenever you have any situation, your distance must be longer than the displacement. Think about this, right? Since distance is always at like whatever path that you do, right? You can go like this, right? From here all the way through all the curve and back to here. And then the displacement is just this tiny short red line. So obviously your displacement is much shorter, but then the time that you take, you can't just reduce the time. It's just still the same time like we did in the calculation. It's still 10 times 60. So it is a must that velocity at most it will equal to speed, and most of the time it will be lower than the speed. The situation where they will be equal is when you have the path moving as a straight line itself. So in this case, the distance and displacement is simply the same, except again displacement you still got the direction. Oh yeah, we forgot to calculate the direction. So from home to school, right? From home to school, so the direction is actually like this, right? This direction. So how you will need to do is, since we have got a compass here, so I think we will have to tell the orientation with the angle. So you don't just say, oh, somewhere between northwest. You don't say that in physics. You have to provide the number. So north, how many degree to west? So that means you have to find out this angle. But then this is a bit hard to find, right? So let's find this angle first. So this angle, you should know how to find it. You can use trigonometry, which you have learned in maths. So tangent theta will be actually 212, because we calculated 212, and the base here is 212 as well. And so if you solve it using your calculator, but then obviously this is 45 degree, so 45 degree, and so that's why the direction is north 45 degree west. All right, you can put a bracket next to the velocity, like the number of the magnitude, we call how fast it is, next to it. Okay, let's talk about acceleration now. So if we try to define acceleration in a very perfect sense in mathematics and physics, then we'll use this. All right, and obviously you shouldn't know what this is, because this is something to do with the maths we call taking the limit, or this one we call differentiation in calculus. So if you don't understand this, it is fine, but notice that this is the most fundamental and perfect definition of acceleration. If we try to simplify in IGCSE physics without understanding calculus, then we can take it as delta V over delta T. And when we say delta, actually it means change of something. Okay, so in physics, okay, whenever you see delta, like this triangle, basically means change of something. So that means it is a change of the velocity over change of time. With symbol, we would put it down as V minus U, and the reason why it is V minus U is because V is the final velocity and U is the initial velocity. You may want to put it down in your notes as well. So if you minus that, then that means you're finding out the change, because in mathematics you also always find the change by calculating nu minus O in total, right? So like today you have got $100, tomorrow you got $150, right? So how much you have change in your pocket? That means it is the new one minus the old one. That means you have positive $50 entering your pocket. So this is the idea as well. Same as when you're applying to anything, when you try to calculate the change in physics. As for the time, then you may ask, hey, then do we have to do like a t minus another t then? Yes. The answer is yes, if you want to. However, for when we try to make it simplified, usually the time that we refer as is the duration. Okay, how long in between that movement or that motion. So it is already a change of time already. So some people would like to put it as T2 minus T1. It's really up to you. Both are fine. If you know somehow it's moving from the 3rd second to the 8th second, for example, then yes, for sure. Then you have to do 8 minus 3 to find out the delta t, which is 5 seconds. For the word formula, you can say acceleration is defined as the change of velocity, not speed by the way, over the change of time. However, I would like to teach you another way of phrasing it other than saying over change of time, because this is quite long to write. What you can write instead is whenever you see something is got divided by delta t, change of time in physics, then you can use the word rate at the front. So you can actually say acceleration is rate change of velocity. And this idea, okay, that delta t change of time, you can use the word as rate. You can apply it basically anywhere in physics. For an example, in physics later on, we'll learn something called powered. You may have heard about it too. And powers for example, of a machine, you can refer it as how much energy it takes over the time, right? A certain period of time. And so if you try to rephrase it, you can say power is the rate change of energy. Okay, instead of saying over the change of time, you can say rate change of energy simply. Lastly, for the unit, it is something that you can work out by yourself if you have given the formula. Let me give you some hints if you don't know how to do it. For example, back to the previous chapter you learned. When you learn about density, density is defined as mass over volume. So by looking at this formula, you can actually work out the unit of density, because you can see that for the unit of the mass, it will equal to kg, and the unit of volume, it is meter cube. So you just keep the fraction there, and therefore the unit of density would equal to kg per meter cube. By the way, when I put this square bracket, it means I'm referring to the unit of that particular physical quantities. So what do you think about the units of acceleration then? Let me give you 10 seconds to think about it. The way you work it out is similar. You have the equation that is A equals to delta V over delta T, right? So for V unit is meter per second and T is second, right? So that's why for the acceleration's unit, it will be meter per second per second. So you can write it as per second like this, but actually no one write that. So you can either write it as meter per second square, or you can write as meter s negative 2. So both of these will be accepted. So let me put it down here. Okay, maybe write over like this. Now we have got 3 examples about acceleration here. I will want you to try it out first by yourself. So pause the video and I'll explain to you later on.
A few moments later.
For the first example, it said there's a ball, so it may be sped. For the first example, it asks you that there's a ball and you are going to release it from rest. So that means the initial velocity is 0. So that is something like, if that's the only thing I got here, is to release it instead of like flowing it. Because when you flow it, then you have some sort of initial velocity that is non-zero, obviously. And it said given that the acceleration is 10 meters per second squared, that means for each second, because when you interpret it, you can see it as 10 meters per second per second. So that means for each second, you change 10 meters per second, because 10 meters per second in itself is the velocity. Okay, so that means for each second, you increase 10 meters per second. So that's why in this table, what you can fill up is 10, 20, 30, 40, and 50, because every time you just plus 10. And this is what it means by having 10 as the acceleration. Now, consider the ball that got flown upward with a velocity of 13 meters per second, not square, per second. How would the velocity be after that? So what it means is you've flown the ball, now not released, but flown upward. But of course, it will come back down. So that's why the velocity, earlier we said the direction is very important, because it starts with 13 meters per second. So think about this, the acceleration due to gravity is always going down. Alright, it want to pull you down. So that means now, if that's the case, then it becomes deceleration. Alright, So in this case, you should be able to think of that in the next second, you should slow down instead of increasing the velocity itself. So it should become 3 meters per second only. So of course the ball still moves up by a certain amount, but then the velocity already become 3 meters per second only, because you have to minus 10 this time, because the acceleration is going down, although the velocity is going up, right? They're in opposite direction. And then after that, obviously you have to pay. Imagine velocity is like the money, so each time you have to pay, right? Minus 10 each time. So this case, then you will start to return the direction, like turn the direction back to downward. So in this case, you will have -7 after 2 seconds, because again this time you have to minus 10. So the ball may be around between 1 second to 2 seconds somewhere. It will start to go back down in this case, right? And then it will be -7 by the time that is up to 2 seconds. And afterwards should be very easy. You get faster and faster, but then going downward. So that will be -17, -27, and -37. Notice that negative means the direction. So it depends on what you define. You can define upward as positive, downward as positive. It's really up to you. So since the question already defined upward as positive, then that means downward is negative. So that's why you end up with the negative number in the later section. Lastly, this is a car that I find from Wikipedia simply, and it's called Porsche 911 Turbo S, whatever it is. It's currently the top 1 car in the world that can accelerate the fastest. So it can accelerate from 0, that means from rest, to 100 km/h in 2.50 seconds. So I want you to calculate the acceleration. If you haven't done that, I can give you a hint, and that is using the equation A equals to V minus U over T. By the way, you have to memorize this equation. So if you haven't tried that, pause the video now and try first.
A few moments later.
Since the question asks us to express the answer in SI unit, that means meter per second square for acceleration, then I would prefer to change 100 km/h to meter per second first. So if you remember what we learned in the previous chapter, then we should be able to convert this to 1 km is 1000 meter, 1 hour is 60 times 60. So this is 1 km/h, then you have to multiply with 100. So that means if you convert that, that will become 27.7. So for V, which is final velocity, I will take it as 27.78, or you should take as much as possible, minus 0. So I will actually keep my number on the calculator with all the decimal point. For the time, it will simply be 2.50. And so divide by 2.50 on my calculator, then you find the answer is 11.1 recurrent. So instead of putting this as answer, or I don't put this as answer, we would prefer doing it with sig fig. So one rule of thumb is that we would look at how many sig fig we have from the raw data. So here we've got actually not this is not raw data. This is 100, right? 3 sig fig, and the time is also 3 sig fig, and so our answer will also take it as 3 sig fig. So our answer will simply be 11.1, and the unit is meter per second square. If you want to have a detailed explanation about how to express your final answer with the correct significance figure or decimal point, I actually have created a video about that. I'll put a link in the description below. You can check that out. As a summary, in this video you've learned about 5 basic concepts in physics, including distance, displacement, and how you can use these two to calculate the speed and velocity. And using the velocity, we can calculate the acceleration as well. So I'll see you again in the next video. Bye.